Hey, here we go. Page 159 of our student journal. We're going to discover the natural base E today and talk about that. What I want you to do to begin with is to take a look at exploration number 1 on that page and complete number 1. All right? You're not going to use a spreadsheet, but you could use your graphing calculator. Just figure out these values. In fact, I want you to keep going maybe for 4 more sequences after it, or 3 more sequences. Okay? So follow that out and see what decimal approximation you're getting to. So keep going for another few sequences. Okay? Okay. That's all right. We're going to go with right there. Okay, that's the values I've got. Now when you get to 1 over 5,040, you get something that looks like that. Okay? Which is 1.98 times 10 to the negative 4th. Remember, when you have 1.98 times 10 to the negative 4th, that's what that E negative 4 means. It means that this decimal moves this way 4 more places. So it's 0.000198. Okay? It's a really small number. So we're getting to a point where we're not going to worry about it. So I'm not even going to worry about that one or that one right now. Okay? If I find the sum of all of these, if I add them up, hopefully we get to this number, really close to it. Okay? So, did anyone add these?
I didn't yet. I said
Sorry, man. Matt, you got them?
Yeah.
Okay.
I didn't calculate the individual values and then add them all together.
Put that big long string in your calculator. Okay. Okay, 1 plus 1 plus 0.5 plus 0.16 plus 0.042 and so on. We get really close to this number. That number is E. Okay. This number, 2.7 blah, 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 is E. We're going to approximate. Just like pi is a number, 3.14 an approximation. I is a number, root negative 1. E is also a number. It's one you use a lot in science. Okay?
Cool.
Yeah. Okay, I want you to take a look at exploration 2. Let's approximate it in a different way. This way is a little easier to understand. So give this one a go. Exploration 2 there. So hopefully you've read through it. You guys, you shouldn't have to continually plug that into your calculator. You put it in once. In this case, x is going to be 10 to the 10 to the first. Oops, don't do that. And then all raised to the x power, which is 10 to the first. And we know 10 to the first is, hopefully you know it's 10, but if you didn't, you could put it in like that. Okay? And you get 2.5937. Bless you. No fun to hurt yourself when you sneeze. All right? And then, remember, you can just go back up to that line and hit enter, and then go in and edit it. So now we just change it to second. It is like a little staircase. You guys not have your books again?
You stop it. I'm so upset.
That she has her book?
No, because she keeps doing that.
Okay, go ahead and finish up that table there. But as you continue that, hopefully your table has started to look like that there. Notice you're getting really, really close to 2.7183.
Hey, that's what he is.
Hey, that is what he is.
Wow.
Wow. Now you know why I named my son E. Bye. Okay? All right. Very mathematical. All right, exploration number 3. Okay? Go ahead and turn the page. Give it a go. Take a look at it, read through it first. Those values for your table, what do you get for negative 2? Nope. Okay, and then? Yeah, we'll go 8. Get smart. 1. 2 point. Okay, and?
7.389.
All right. Hey, building our table now, right? Or excuse me, building our graph, plotting those points. Describe your domain and range. Okay, hey, we're going to check our work. Okay, so our domain, all real numbers, range, y is greater than 0. It's a rational number, and any real number can be used as the exponent. All right, making sure that we understand why our domain is all real numbers. Remember, it doesn't have any holes. Any real number can be used as the exponent. That's why. Okay? Actually, it's x, right? Okay. Oh, man. Some of the best stuff, man. All right. Hey, I'm going to let you do the bottom part on your own at a later time if you want. Okay. Tell your neighbor what value E is.
2.718.
Okay. Now I want you to locate it on your calculator.
Oh, we already did that.
Find E and push the button and see what you get.
I found
Hey.
E to the X, so I just put E to the first.
Oh, my battery's low. Hey, good point, you guys. There's E. There's E, and then there's E to the X. E is second division. Simple. Okay? That gives you E. You hit enter, and there it is. If you put E to the power of X, which is second ln, which is right down here, that's fine. But if you push second ln, it's going to put that power up there, and you're going to have to put the first power if you. Okay? Capital E is not the E. Well done. All right. Very good. I want you to take a look at page 162 of your student journal, please.
I'm looking at it.
All right. Actually, go to 161 real quick. Some notes there. Hey, just to kind of summarize. Hey, E is our natural base. E is irrational. That means, well, remind your neighbor what irrational means. Other than it's not rational. And it's not a crazy number.
It's repeating forever and ever and ever. Like,
Okay, volunteer, what's irrational mean? Yes. Goes on forever, doesn't, yeah. Can't be written as a fraction, doesn't terminate, doesn't repeat. It's a decimal that keeps going on forever, okay? A function of the form y equals a, e, or a times e, r x power is called a natural base exponential function. They call it a natural base because e is called the natural number. It is one you're going to see appear a lot in sciences. Okay? A obviously has to be greater than 0. We still have some kind of the same rules on our A and our B terms. A is greater than 0. R has to be greater than 0. Or when A is greater than 0, R has to be greater than 0. When A is greater than 0, R can, and R is less than 0, the function is a decay function. If it's greater than 0, it's growth. That was really lame. All right. Okay, right back up here. Except for you got the whole class off task. Continuously compounded interest. Okay, so if you have a bank that ever offers you continuously compounding interest, you take that deal. Because that means as you sit here and breathe, your money is collecting interest. It's being compounded every second of every day. That's nice. Okay? Continuously, when you see PERT, that is the function, or that is the formula for continuously compounding interest. All right? P is your principal, R is your rate. Very good. You guys, you're going to see things continuously, like in real life, when you're dealing with science. If a leaf falls on the ground, that leaf is continuously decaying. It doesn't like decay like every hour. It's like, oh, it's time to decay right now. Okay, I'm done. And then the next hour, oh, it's time to decay. Okay, now I'm done. Okay, it's continuously doing that. That's why you use E a lot in science. No, we're not going to go through that right now. That's a lot of work, man. No, that takes us way off topic. All right, right now, number 1, give it a go. Number 5 after that. Okay, since they have the same base, that's just e to the 3rd power. Okay. So everyone who found the answer, you're like, oh yeah, e to the 3rd power is this. Like, you have this big long decimal that you cut off. Okay? That's not simplifying. This is simplifying. Right? Oh yeah. You're going to be working on simplifying. Hey, graphing. In this one, is E growth or decay? Why is it going to be decay?
It's to the negative x.
Yeah, we have a negative, and it's not because necessarily the rate's negative, but what happens is when you have negative x, that's 1 over e to the x, right? 1 over e to the x. Okay? So when we have 2 times 1 over e to the x, remember that 2, what is that 2? That's our y-intercept, yeah.
Well, we ever do, like in algebra, we went through how they originally found the quadratic equation. Will we ever do that?
We can't, yeah, with e?
Yeah, with y.
Well, that's kind of what we did at the beginning with our exploration. Yeah, it's just one that continually starts appearing. We do it in those different patterns that we explore. Hey, I want to know what this equals when x is -1 and when x is 1. When someone gets it, let me know. Yeah, what do you got?
When it's -1, it's 5.44 gravity, and when x is 1, it's 0.74 gravity.
So 5.44? Okay, so 1, 2. Anyone else have that? Yeah? Okay. And -1 is point.
Positive 1 is 0.74.
Thank you. Positive 0.74. I think the next one's right about down there. 0.27. Thank you. All right. So you start seeing that it's approaching what line? This x-axis. Okay. That is your asymptote. Very good. Okay. All right. Hey, go ahead and turn the page, please.
Wait, turn the page or just go to 163?
Okay. Yeah, 163. Next page. You guess you don't have to turn it. I actually have to turn it. See how much more effort I had to put in? I know. Okay, without graphing this, I want you to tell your neighbor what's going to happen to that function. How is it going to differ from e to the power of x?
This one
Okay.
changed the y-intercept.
Hey, volunteer. Good. Yeah, well, it drops your y-intercept down to -3. Very good. Yeah. You guys catch that? Okay, so here, y-intercept out here in front is 1, right? Okay. So when we plug a 0 in for x, we get 1, and 1 minus 4 is -3. So it moves our graph down. So if you think about your y-intercept that was at 1, starts up here, when you have -4, that's like our k term, right? So if we think of this as y equals a times b to the x minus h, all plus k, that 4 out there is our k term. It's shifting this point down 4 units.
Wait, does that mean with like 10, the +3 makes you still go the opposite way, so left 3?
Yeah, very good. This one's going to move you, your y-intercept, left 3 units.
Oh my god.
Pretty exciting stuff. Okay? So yeah, you guys, you can start thinking about the shifts of your graph before you actually graph it. Okay, so if I think originally my y-intercept is where on this problem? At 2. However, it's 2 because of that. That's your a term. It moves over 3 units. Unfortunately, well, actually not unfortunately. Fortunately, so by the way, you're not done graphing those. I'm just kind of pointing out a few things. Fortunately, on this one, you get to experience some other stuff. You usually start at 1, right? Okay? However, that 1, what does this do? Okay, actually, this is a vertical, right? And what's this? That's also a vertical. That's a reflection in the x-axis. So take this and reflect it. And then move it up 5. That is our starting point. Hey, guys, really what I'm trying to do, I know this is a bit confusing, but this should be, like when you start thinking about things you know and you don't know, you're not familiar with E, but you are familiar with graphing, and the branches you should be holding on to, like as you climb this tree of math. I know. Awesome, right? All right. Hey, the branches you should be holding on to, seriously, and no pun intended, because these eventually will be called branches as well. Hey, the branches you should hold on to are these pieces you know. You know the HK. You know your reflections. We studied that. You guys hated chapter 1 because of it. Okay, we spent a lot of time on it. So use that. Hey, we reflect, and then we move it up. This point that was here gets reflected there over the x-axis, and then it moves up 5 units. Okay? Now, did you have to do that? No, you could have just started picking values for x and solving. Why would you do that? Because you want to relate it to what you already know. That way it's easier to remember. Okay? All right, your assignment is to finish the extra practice on page 162 and 163. Okay?